Hello everyone. Today I am going to talk about an important concept in Java, which is abstract classes versus interfaces. This topic comes under object oriented programming and it plays a major role in writing clean, scalable, and maintainable code. In real world programming, we often face situations where we don't want to define everything completely. We just want to define a structure or a blueprint. That's where abstraction comes in. In this presentation, I will explain what abstraction is and how Java. At first, these two might look confusing because both are used for abstraction. But once you understand their purpose, you will realize they solve different kinds of problems. Think of this session as not just theory, but as something that helps you design better programs. Java supports abstraction, how abstract classes are, what interfaces are, and finally the difference between them. By the end, you will clearly understand when to use each one of them. Before we jumping into abstraction, let's quickly understand object-oriented programming or OOPS. OOPS is all about modeling real-world entities using code. Instead of writing everything in one place, we break problems into classes, objects, behaviors. Among the main principles of OOPS, abstraction is one of the most powerful because it helps manage complexity. It is a programming style where we structure code using objects and classes. There are four main pillars of OOPS: encapsulation, inheritance, polymorphism, abstraction. Today, our focus is on abstraction. In real life, think of something like a car. You know how to drive it. You use the steering wheel, accelerator, and brakes, but you don't need to know how the engine works internally. That's where exactly abstraction does in programming. Imagine you are using a food delivery app. You just place an order. You don't care how the restaurant prepares it, the delivery system works. The payment is that is hidden from you. In programming, abstraction does the same thing. It hides unnecessary complexity. It exposes only useful operations. It hides complexity and shows only what is necessary. Java provides abstraction in two main ways: abstract classes, interfaces. An abstract class gives a base structure for with some implemented methods and some unimplemented ones. An interface, on the other hand, is like a strict contract. It only defines what should be done, not how. Think of it like this: abstract class. I will give you some work done and you complete the rest. Interface. You must follow these rules completely. Both are used to achieve abstraction, but they serve slightly different purposes. For example, when you press a button, you accept an action. You don't need to know the internal logic. In Java, abstraction allows developers to define methods without implementation, force other classes to provide details. This creates a clear structure in the program. Let's understand the abstraction more clearly. Abstraction means hiding internal details, showing only essential features. For example, when you use a mobile app, you don't see the backend code. You just interact with buttons and screens. In Java, abstraction helps us reduce complexity, improve code reusability, make systems easier to maintain. It allows developers to focus on what an object does instead of how it does it. Now, let's break abstraction into key points. Understand its properties. Declared using the abstract keyword cannot be instantiated directly, can have both abstract and normal methods, supports inheritance. Abstract class is useful when classes are closely related. Think of it, think of a parent class employee, common methods, salary calculation, abstract method job role. Each employee type implementation it implements it differently. Abstraction hides complex logic from the user. The user interacts only with necessary functions. It highlights only important functionalities. For example, calling a method without knowing its implementation. Reduce complexity. Large programs become easier to manage because unnecessary details are hidden. Real life example like think about an ATM machine. You withdraw money without knowing how the banking system processes it internally. That's abstraction in action. Now let's talk about abstract classes. Java provides two main tools for abstraction, abstract classes and interfaces. Now, here is the key difference in simple terms. Abstract class gives partial implementation, interface gives only rules, no implementation. Abstract class is equal to combination of definition plus behavior. Interface is equal to only definition. We will now explore both in detail. An abstract class is declared using the keyword abstract. You cannot create objects of an abstract class. It can have both abstract methods and concrete methods. It acts as base class for other classes. For example, imagine a class called animal. It may have method like eat already defined, but a method like sound may be abstract. Different animals will be implement sound differently. So abstract classes allow code reuse partial abstraction. All methods are abstract by default because it allows unrelated classes to follow the same structure. A payment interface can be implemented by credit card, UPI, net banking. Each one works differently but follows the same contract. Let's go deeper into abstract class features. It supports inheritance, it can have constructors, it can have instance variables, subclasses. Subclasses must implement abstract methods. Think of a template for vehicles. Common features, wheels, engine already defined. Specific features, fuel type, speed defined by subclasses. So abstract classes are useful when you want to share code among related classes. Now let's understand interfaces. An interface is like a blueprint of a class. No method body. A class must implement all methods. You cannot create objects of an interface directly. If you define an interface playable, it may have a method play. Any class implementing it must define how play works. So interfaces enforce a strict contract consistency across classes. Interfaces are very powerful because they support multiple inheritance. Java does not allow multiple inheritance with classes, but it allows with through interfaces. For example, a class can implement runnable, serializable, comparable, and all at the same time. Think of a universal charging point port standard. Any device that follows it must implement the same behavior. So interfaces ensure standardization, flexibility. Now, coming to the conclusion, let's summarize everything. Both abstract classes and interfaces are used for abstract class, partial abstraction plus shared implementation, interface, full abstraction, and multiple inheritance. When we have to use them, use abstract classes when classes are closely related. Use interface when you want to contract across unrelated classes. Choosing between them depends on your design needs. Abstract classes allows partial implementation, interface allows full abstraction. Abstract class supports single inheritance. Inheritance supports multiple inheritance. Abstract class is used for related classes. Interface is used for unrelated classes with common behavior. Thank you.